solving systems of equations. But before we can really dive into doing that algebraically, we have to make sure that we're totally confident about how to go about doing that graphically. So I want to start us off with an example, and I want you to take notes pretty much exactly as I do. So let's say we have two equations. Let's say one of our equations is y equals 3x minus 4. Okay, good, that's on there. And the other equation is y equals negative 2x plus 6. So when I say these are equations in standard form, what I mean is that these are equations, standard form, means that these are equations in the form y equals mx plus b. I know some of you have seen that before, but I think that we're starting to forget what our m and our b actually stand for. So our m refers to, goes by a couple of different names. That could be rate of change. I'm going to abbreviate that, ROC, or some people call it the slope, and some people call it the growth, and usually that's referred to with our variable m over here. Our variable b, that's telling us about our starting point. The formal name for that is our y-intercept. And the correct way to write both of these in terms of format, our growth, that's just a coefficient, just a number multiplied by x. So I could write, if a question asked me, what is the rate of change? I would give the number that is multiplied by x. So in let's call this equation, let's see if that's even going to fit on there, equation 1, then equation 2. So in the case of equation 1, rate of change I would say m equals 3. But if I was asked y-intercept, that's actually referring to a point. That's referring to the point where the line crosses the y-axis. So we're going to actually give that in point form. We're going to say that that is the point where x is 0. Remember, 0 is where we're crossing the y-axis. So where x is 0, and our y value is equivalent to our b value. In this case, that's negative 4. Okay. In our second equation, we want to know the rate of change. I'll go ahead and abbreviate that this time, rate of change. That's the number multiplied by x, and in this case it's negative, so m equals negative 2. And our y-intercept, go ahead and abbreviate that y-int. Remember where the line crosses y-axis, so the x value is going to be 0, and that b value, 0 and 6. So we've got two lines here. When we're talking about two lines, or more, but in this case we're just going to stick with 2. We're talking about a system of equations, but we're also talking about a system of lines interacting on a single set of axes. So I could ask two questions and really be asking the same thing. I could say, what is the point of intersection? Or I could say, what is the solution to the system? And these are really asking the same question. They're asking what point in the form of x, y, what point, if I put in the x and y, would make both of these equations true? And what point, if I were to graph both of these equations, would be where they cross each other? So today we're going to start by just looking at graphing them. So make yourself a straight edge. I like to just fold a piece of paper in half a couple of times. And we'll just come in here. You may need to do this on the back side of your piece of paper if you don't have enough room on the front side. We're going to come in here and we're just going to make a set of axes. And I think that probably a 10 by 10 or even an 8 by 8 axis system should be enough room for us. I'm going to go ahead and put mine like this and then label it afterwards. Remember, to be a complete set, let's scooch this up a little so we can see everything. To be a complete graph, we want to make sure that we show that our axes are infinite, and we want to make sure that we label them, and we want to make sure that we give regular increments. So 1, 2, 3, and up. And remember, this is our origin. We're not labeling that point. That point is 0, 0, but backwards, there's -1, -2, -3, downward. I like to write my numbers right on the line, so I associate them with the line that I'm associating them with. Okay, so to find the point of intersection, the first thing we need to do is just make both lines on our graph. So pretty easy once we've gone ahead and done the work of telling ourselves what our y-intercept and our slope are. For each line, the first thing we can do is start by putting down our y-intercept. So in line 1, our y-intercept was 0, -4. I know my first point is going to be right there. And then my slope, I can think about my slope, I like to think about my slope in terms of rise over run. That means how much I go up for how much I go over. In this case, I've got a whole number slope. I can think of 3, though, as being equivalent to 3 over 1. And then I can use my rise and my run. So 3, that would mean from my starting point that I put down here, I'm going to rise 3 and go over, run over 1. And I'll do that a few times to get a couple of points. And then I'll use my nice handy-dandy folded straight edge, come in here, and connect my line. There we go, roughly. And then for my other line, same thing again. Where's my y-intercept? Well, it's going to be somewhere on my y-axis. Oh, and it's all the way up at 6. There's that point. And then this one's a little bit trickier because our slope is negative, but it's still a whole number. That means we're still doing the equivalent of -2 over 1. Remember, 1/2 sort of wholes. Anyway, so that means, negative means I'm going to go down 2 and over 1. Down 2 and over 1. Down 2 and over 1. And again, I can go in and connect. Just put that right there. Now, I have graphed my system of equations. I have a graph in which they both exist, and I can see there's my point where they're crossing. So just by looking at the graph, I can say those lines clearly cross at, let's see, well, my x value is 2, and my y value is also 2. So I've been able to solve my system of equations by finding the point of intersection. And I can check that this works algebraically by looking at each of my original equations. So in equation, let's see, I'll do that over here. Equation 1 was 3x minus 4 equals y. And so I just want to take my x value and put it in for x, and my y value and put it in for y. So I'm going to end up with 3 times 2 minus 4 is hopefully, if I did this right, going to be equal to 2. Oops, yes. Just going to make sure I actually write the numbers down right. So 3 times 2 is 6 minus 4. Does that equal 2? Why, yes, 2 does equal 2. So it definitely works for my first line. That was this line. Right, I'll go ahead and label that 1. And I can label this one just to keep it straight, 2. And for my second line, I have the equation of -2 times x plus 6 equals y. So if I do the same thing, put that in for my x, and put that in for my y, hopefully, when I simplify this, it will also work. So -2 times 2 plus 6, is that going to equal 2? -4 plus 6. So, what this is saying is, these two values make this equation true. and these two values make this equation true. So when x is 2 and when y is 2, that's when both of these equations are true. That's the solution to the system, the one place where these equations mean the same thing. And I just want to do a little bit more touching on rates of change, on slope, because I think that was a little bit confusing for some people in terms of getting it actually onto the graph. So if you've got a little extra room, or if you need to turn your page, go ahead and do so. So slope, when we're looking at an equation in standard form, when we're looking at a y equals mx plus b, sometimes that m is going to be positive, sometimes it's going to be negative, sometimes it's going to be a fraction, I'll just show that a over b, and sometimes it's going to be a whole number, just a. And all of these tell us slightly different information about what to do with our graph. But essentially, all we're going to do is we're going to put down 1 point and we're going to figure out how much to rise and how much to go over for each increment. So let's say I had a slope of 5. That's not in rise over run format, but remember 5, I'll just do an equal sign. 5 is the same thing as 5 over 1. So now I know if I put down my starting point, I'm going to rise 5. Was that 5? That's 4. Rise 5 and go over 1. And now if I connect these 2 points, that'll be the correct slope. If I had a slope of 1/5, well, that's already in rise over run format. That's already a fraction, right? Rise over run format. So in this case, if I had my starting point, I would rise 1 and go over 5. And if I connect those, that's going to be the tilt of that line. If I had a slope of 7 seconds, right, I would want to rise, well, let's see, I better start low enough to make sure I can actually go up 7. So rise 7 over 2, and now if I connected those 2 points, I would have the right slope. So we're going to practice a few of these. Make sure that your notes are as full as possible, and the video will be on the website.